Have you ever thought about such a question? Is the universe cloudless and vast? What exactly is beyond the universe? Next, we'll delve into the solar system, the Milky Way, and the largest structure in the universe that we've been able to observe. As you embark on an exciting journey through the universe, let's start with our own solar system. The solar system is home to the Earth, which includes the Sun, the 8 planets, and countless moons, asteroids, and comets. However, even in this insignificant corner of the universe, there are endless mysteries. Scientists draw conclusions based on simulations of research and observational data. The closest cosmic object to Earth is the Moon, which is close to us. The distance is about 384,400 kilometers. Although this distance is already far from that in the measurement of the Earth. But if we go to the Moon on a civilian airliner with a speed of 800 kilometers per hour, it takes at least 480 hours of your time. This number is astonishing. Let us deeply appreciate the infinite extension of distance in the universe. However, the spectacular beauty of the solar system is not just about the Moon. If the orbit of Neptune is used as the boundary of the solar system, the radius of the solar system is about 30 astronomical units. This is equivalent to 4.5 billion kilometers. At the same airplane speed, it takes at least 642 years to travel to Neptune. If you take the Oort cloud as the boundary, the radius of the solar system will be more than a light year, equivalent to 9.46 trillion kilometers. This makes us realize, even inside the solar system, interstellar travel is also a big challenge. Once, humans have launched 5 deep space probes. The most distant was Voyager 1, launched in 1977. At a speed of 17 kilometers per second, Voyager 1 flew outside the solar system. About 24 billion kilometers have been flown so far. However, to fly out of the solar system, it will take at least another 17,000 years. This is for humans with a limited lifespan. An almost impossible feat. The solar system is just one part of the universe. However, even in this microcosm, we are also deeply aware of the vastness and infinity of the universe. To understand the vastness of the universe, we also need to dig deeper into our homeland. That's the Milky Way. The Milky Way is the galaxy in which the solar system is located. It is also the universe around the Earth. Its scale is even more incredible. The Milky Way is about 100,000 light-years in diameter. It contains tens of billions of stars and planets. This number is almost unimaginable. But even in the future, humanity develops a light-speed spaceship, nearly 300,000 kilometers per second. It will take at least 100,000 years or more to leave the Milky Way. It's a daunting timescale. Beyond the limits of our limited lifespan and technology, the Milky Way is not an evenly spaced interstellar home. Its structure is divided into 5 main spins. They are Insean coins, Orion coins, Ruler coins, Centaur coins, and Hunan Cross coins. Even inside this galaxy, to travel to other interstellar neighbors, it's also a huge challenge. The nearest star is called more than a sporadic star, located about 4.2 light-years away. Although the distance may not seem far, but with the current technology, travel is at least needed than sporadic. More than 73,000 years. This remains an unattainable goal. Even if in the future, humanity has developed a light-speed spaceship, nearly 300,000 kilometers per second, it will take at least 100,000 years or more to leave the Milky Way. However, when we look at the universe from a higher perspective of space, the Milky Way is also only one in the universe. Insignificant existence. Above the Milky Way, there is also a larger observable universe. It is the extent of the universe that we can observe. It represents the visible part of the universe that humans have. The sheer size of this universe is incredible. It cannot be measured by ordinary scales. Scientists estimate the diameter of the observable universe is about 93 billion light-years. Within the observable universe, there are tens of billions of galaxies. Each galaxy contains tens of billions of stars and planets. These galaxies exist in a variety of shapes and sizes. Some are oval in shape. Some are spiral-shaped. Some are irregular shapes. And then really many galaxies between. Occasional collisions also occur. Collisions between galaxies are extremely complex and spectacular astronomical events in the universe. This leads to a series of interesting effects and phenomena. The first is to trigger the formation of new galaxies. When two galaxies are close to each other and collide, their gases, stars and planets may intertwine with each other. Formation of entirely new galaxies. These newly formed galaxies may have unique morphologies and properties, very different from the original galaxy. Second, in galactic collisions, there may be interactions between stars, which can cause some stars to be thrown out of the galaxy and become isolated stars or drifting stars. On the other hand, some stars may be gravitationally captured and added to new galaxies, and galactic collisions can cause massive compression of gas and dust and gravitational pull-out, prompting the formation of new stars. These newly formed stars may have been born in the core region of the colliding galaxy or elsewhere, increasing the total number of stars in the galaxy. Collisions between galaxies can also trigger superstar explosions. Interactions and collisions between stars can cause some stars to turn into superstars. This is the process by which a star explodes at the end of its life cycle. These superstar explosions unleash a huge amount of energy. It has an important impact on the evolution of surrounding galaxies. Collisions between them also trigger the activity of supermassive black holes. The core of galaxies usually contains supermassive activity. Galaxy collisions can lead to interactions between black holes. The activity that gave rise to the black hole. Intense radio radiation is generated. X-ray radiation and ejected material outflow. These are all sights observed by astronomers. So the universe is vibrant. It has not only shaped the evolution of galaxies, prompting the creation of new stars and planets, it also provides a unique opportunity for the interaction of matter in the universe at different scales and time scales. These observations and studies help us to better understand the evolution of the universe. And on top of the observable universe, it is possible that there are multiple universes. According to the multiverse theory, each universe has its own unique laws and properties of physics, probably quite different from our universe. These universes are independent of each other. They do not interact or interfere with each other. They are like an infinite number of books. Each book represents a universe. Each universe contains a unique story and rules. The concept of the multiverse originated from the in-depth study of the expansion of the universe and quantum mechanics. One theory goes, in different regions of the universe, the laws of physics may evolve in different ways, led to the formation of the multiverse. This view has sparked extensive discussion and research, but it is still a scientific hypothesis at the moment. The concept of the universe has stimulated the discussion of the structure and possibilities of the universe. It reminds us that the universe can be much more complex than we know. Regardless of the ultimate truth, the ideas of the multiverse all demonstrate humanity's disdain for the mysteries of the universe and the infinite possibilities of scientific exploration.